Last semester in college algebra, we talked about even and odd functions, both in terms of their algebraic definitions, which you see here, and also in terms of graphical characteristics that they have. If I look at the graph of an even function, and probably the most familiar one is y equals x squared, this parabola, you can see the symmetry across the y-axis. The thing that causes the symmetry across the y-axis is the fact that if I put a positive input, say x equals 1, into the function, then what I get back is this y value, in this case 1. If I put negative 1 into that function, then I get an output of 1. Notice that even though the input is opposite, the output is exactly the same. That causes symmetry across the y-axis, and that tells us that we have an even function. Now, just because the function starts out even as a parabola, that doesn't mean that if I shift it, it's still going to be an even function. It's just the parent function that we're talking about is an even function. Now, we can look at the odd function in a similar way. If we look at the graph of an odd function, say y equals x cubed, a function that goes through the origin like this, and it has one arm down and one arm up, looks a lot like a tangent, but it doesn't have any asymptotes on it, then we can see that we've got symmetry about the origin. If I were to rotate this graph 180 degrees, or stand on my head and look at it, it would look exactly the same way. It would have the exact same shape. So that's symmetry about the origin. Remember, we said that the O's go together. So if I have an odd function, then it's origin symmetric. The other thing that you notice about the O's is that you get the opposite. And here's what I mean by that. If I put in a positive input to this y equals x cubed function, say 1, then I get this positive y value. It doesn't have to be positive, but I get a y value of 1. If I put a negative 1 as my input, then I get a y value down here that's exactly the opposite of that y value that I got at positive 1. So this ordered pair is negative 1, negative 1. So when I put the opposite input, I get exactly the opposite output, and that's what this algebraic statement means. That's what causes the symmetry around the origin. Now, what does this have to do with trig? Well, our 6 trig functions, of the 6, 2 of them are even and all the rest are odd. So we can judge even or odd of these parent trig functions based on the graphs of the functions. So you can see this is a cosine function. It's either sine or cosine because of the shape. You can tell it's cosine because when the angle is 0, you're starting at a high point. You're starting at the maximum of the cosine. So then you have this cosine shape right here. That's a full period. This shape is reflected on this side right here. If you fold this on the y-axis, then this shape is going to lie right on top of that shape right there, which means that this is symmetric across the y-axis, and that makes it an even function. So the cosine trig function is an even function. It's one of 2 even functions. This is the graph of the sine. You can tell because it starts at the origin, and then it reaches its maximum, and then its minimum, and then back to 0. If you rotate this graph 180 degrees, then it looks exactly the same, which is a characteristic of an odd function. It's origin symmetric. So the sine is an odd function. This is the graph of the cotangent. You can tell because it's always decreasing and because it's shifted over from the origin. This is not symmetric across the y-axis, as a lot of people at first think it is. If I fold this graph on the y-axis, then this graph would be going in the opposite direction that it needs to go. But you do notice that if I rotate it 180 degrees, it looks exactly like the original. So the cotangent graph is also an odd function because it's origin symmetric. This is either the secant or the cosecant. And the way you can tell the difference is to look at the reciprocal of those. If this were a cosecant, that would be reciprocal of sine. And we know that sine starts at the origin, then reaches its maximum, back to the midline, to the minimum, and then back. So that graph of the sine is not fitting between these U-shapes. However, if we use the cosine graph, it's going to start high right here. It's going to share the minimum. The maximum on the cosine is going to be the minimum of the secant graph. and then the cosine would go through the midline where there's a vertical asymptote. There would be a minimum on the cosine, which is a maximum on the secant, then back through the midline, another vertical asymptote, and then back to the high. So that cosine graph would fit right in between our U-shapes, meaning that this is a secant graph that's shown. Notice if I fold my graph on the y-axis, then this arm is going to lie right on top of that arm. This U-shape is lying right on top of that U-shape right there. So here is the other even function. The secant is an even function. Now notice, as we already talked about, the cosine and the secant also have the reciprocal relationship. So that's another way you can remember that these go together. Those are our only two even functions. All the rest are odd. So this is a cosecant graph. It's going to be odd. This is a tangent graph, and it's odd as well. You could investigate those graphically, but we'll just group them right there. These are the fundamental identities. Most of them we've already talked about. They've already been recorded on your plate. But these negative angle identities are the ones that go with the even and odd function concept that we were just reviewing. So these need to be added to your plate. Notice that if I have sine negative theta, that's equal to the opposite of sine theta. My negative input here is a positive input right here, and the negative is just written out front. That has nothing to do with factoring out, because sine and the angle are not multiplied together. This identity is based on the definition of an odd function. So don't think that you're factoring that negative out, because if that number were a number, if that negative were a number, you would not be able to bring the number out to the front. It's only because it's a negative angle, and we can change it to a positive angle if we put the negative out front. So you have that for each of these functions. Once you write these on your plate, you may want to box these in the middle, the cosine and the secant, just to remember that these are the only even functions.